In this video, we will understand about the non-destructive technique that is used to test the food quality, and it is done by non-invasive technology. See, whenever we conduct one analysis of food, what we do, we generally take the sample. By taking sample, we need to break the bakes or any containers, and so that is called destructive ways of taking sample or analysis. But what is non-destructive technology is that we don't actually take the sample from the lot and directly we make testing, and not we make, actually the system, the technology make, which is having some sensors, some optical instruments which can sense there is some defect, and automatically it will instruct the machine to remove that product from going to the production line. So this is non-destructive techniques and is the non-invasive techniques used for what? Used for inspecting, testing, or evaluating materials, components, or assemblies for discontinuities or differences in characteristics without destroying the serviceability of the part or system. It helps to determine the surface or internal defects without interfering with the material and its suitability for the service. Then, limitations of traditional methods of food quality evaluations. So just now we have discussed that traditional methods is also present for analysis of food, and what are those limitations? Significant distortion or damage to the product. We have to make some damage to the product so that we can understand the characteristics of that product, and higher requirement of time and manpower, economic losses due to product destruction. There is also some loss of money and major quality in batches. We have to take batch because it cannot be continuous process. We have to measure it by batch wise batch we have to measure. Then determine only one or a few properties of the material. We can't determine all the properties of that material because there exist some limitations in this traditional methodology. Then advantages of non-destructive technology used for internal quality assessment of all the items. Assessment is fast, user friendly, cheaper, and accurate. Increase product safety and reliability. Product safety is also increased, and reliability during operation. Then enhances the reputation of manufacturer as producer of quality goods, because when you are using non-invasive technology, you are giving the product which is not having any error to the consumer, because you are not making any kind of sample. Okay, and boost scale of product any and provide economic benefit to the manufacturers is also benefited by the help of this, because there is a boost in the economy of selling, or the business will be twofold increased. Then there exist some limitations of NDT also. There are expensive installations because some instruments are there, you have to install it, a lot of money is there at starting for installations, and require experts to work with the instruments. You also need some experts because NIR is used, some infrared technology is there, so a lot of experts are required to utilize these systems. Then proper maintenance of equipment is also required, because sometimes the maintenance is required, the machines are fitted that will go damaged, will have some errors, so there exists some problem and you need to call the expert to repair that system. Then application of NDT in food technology. See, in reception area, control of raw material you can do, reduce product losses, improve consumer perceived product quality. Then process control you can do, that is the main thing, that both online and offline. When online means the production is going on and at the same time you are doing non destructive testing and the product is identified is good. If it is good, then the system will pass that out, and if not good, then it will be taken out by the machine. Then standard instrument setup is used in offline systems. The analysis of intermediate or final products. Screen large number of samples. You can screen a lot of samples, even whole products you can test. Then product development and storage testings. That is there. Follow the properties of one single product over time. Then you can also go for research. What are the different changes going on in the field of research, and also you can analyze. Then sorting of apples using non-destructive technology, that is easy because you can check based upon the morphology of the this apple. You can get the idea, and you can either remove that apple, or you can sort it out. Then online compositional analysis of food using near infrared analyzers. You can do it by the help of near infrared analyzer, NIA. Then non-destructive methods to evaluate the quality characteristics of agricultural and food products. By different methods, what are the benefits you can make? See, optics, by using optics. Optics means you can use spectroscopy. Okay, some light observance will be there, some light will be observed by the material and it will reflect something, and based upon that you can calculate the quality of the materials. All these things are dealt with what? Optics, like size, shape, color, outward effects, all these things by the help of image analysis. Then spectroscopy analysis, you can understand the sugar, acidity, soluble, solid content, color, internal and external defects, stiffness, all these things you can understand, because spectroscopy of NIR type, what it does, it will calculate by the help of observance how much the material is observing. Based upon that you can quantify the quality of that material, the taste, acidity, solubility, all those things. Then x-ray image and CT, computer topography you can use. That the inner cavity structure, the inner cavity structures, the degree of maturity you can do by the help of mechanics. Ultrasound you can use, acoustic you can use. This ultrasound, what it can check? It stiffness, visco, elasticity, internal activity, density, sugar. And acoustic, stiffness, viscosity, both are same, because ultrasound will give some sound to that material, and based upon the reflect sound you can that machine can get it. Then electromagnetic, NMR or MRI, it can measure what? Sugar, moisture content, the inner cavity. Then chemical, E-nose. What is that? E-nose can be made. E-tongue can be made. See, E-nose means electronic nose and electronic tongue. By that you can measure the acidity, sugar, odor, flavor, etc. Then optics, by the help of optics you can do what? Imaging analysis. Image the product. See, when you are doing the analysis, you have to create a library in the sense, what are the characteristics of good material, you have to check, you have to make the library, and you have to feed into the system, and you have to make the bad quality materials pictures. And then when the system will process, the system will process, what will happen? The product will be checked by the machine, and based upon that optics it will take the image, and if the image is good, then the machine will allow to production line, and if it is not fit to the wrong image, sorry, not fit to the right image, then only it will not allow to the production line. So based upon that you can do that machine will do them. Then hyper spectral imaging system principle is what? Difference in the chemical compositions and inherent physical structures reflect, scatter, absorb, and emit electromagnetic energy in distinctive patterns at specific wavelength. Different wavelengths, in that it can measure the distinctive patterns. Then spectral signature of pizza. This characteristic is called spectral signatures or spectral fingerprint, or simply called as spectrum. See, different food materials. Suppose you take the example of a pizza. This pizza is having what? One is having cheese part, one is having onion part. Based upon that, bread, meat, different material is having different spectrum. You see, this material is having like this spectrum, this material will be having like this spectrum, and it will having like this spectrum. But suppose your pizza is having not good material. Suppose by mistake your pizza is having some iron content in that, iron source, some physical contaminant. What will happen? The spectrum will be not equal to this library. This is library. And when what happens when magnet or any other material, that material will have a different spectrum, and based upon that a different spectrum, what the system, that machine, it can recognize any deviations, and then it will say the system to remove that wrong pizza. By that, what happens? The consumers who will get that pizza will be satisfied with the service. That is the main purpose, and the business will be improved. Then you have understood this, that same things he has told. Then multispectral imaging systems. Different images are having different spectral, multispectral imaging system is also there, and at the same time a machine can check different multispectral, different spectrum it can check, and different products. Suppose you are the production unit is producing different kinds of product, and a single machine is fitted. At that moment, what happens? It can check multi-spectrum, and based upon that, it can check the quality of the product. Then observance spectra of wheat and peanut flour. See, 8 sample of peanut adulterated in flour were prepared, ranging from 10 to 0.1% by weight. So different adulteration also you can check by the help of this entity. Precisions of multispectral systems to detect peanut flour. Peanut flour spectrum will be different. See, this is some bias is there. This 0.303% is existence of bias, and that little amount of bias will be analyzed by this entity, and by that it can check any adulteration also. While you are receiving a raw material, that also you can utilize this technology. Then spectroscopy, simple, accurate, and expeditiousness require minimum sample preparation. See, spectroscopy is also one technology that can be used in this NIR, near infrared resonance. What is the principle? Based on optical properties that respond of matter to near infrared, where the light either get absorbed, reflected, or transmitted. That we have discussed. See, a different matter will have different response to the entering light. How much it will observe. A single metal will a different matter will have different kinds of transmittance, reflectance, and observance, and based upon that data, you can use that data for quantifying or qualifying that, analyzing that material. Okay, concept of NIR. What is that? Reveals informations about chemical properties and surface structures and the chemical properties can be analyzed. Then what? Reveal moisture microstructure of the tissue. Then presence of chemical compositions. See, emitted is there, scatter is there, absorb is there. Emitted will show what? It will reveal information about chemical properties and surface structures. Scatter, what it will reveal? Microstructure of the tissue. And observe, presence of chemical components. Okay. Then, but NIN is what? It is restricted to fruits with homogeneous pulp and thin skin. If skin is thin, then only it can analyze the data. But it can assess what? Soluble solid content, titrate, tritable acidity, or other physiological properties in intact fruits such as in prune, stone fruits and apricot. High penetration in range 0.7 to 0.9 micrometer. सो दिस NIR स्पेक्ट्रोमीटर मेजरिंग मेथड्स क्या क्या वहाँ पे है ना. फुल ट्रांसमिटेंस मेजरिंग सिस्टम्स. Transmittance can be measured by the help of detector. Here the light source is there, here the food material is there. When light is entering to this food material, there will be some transmittance, and that transmittance will be detected by the help of these detectors will detect there. So this is full transmittance measuring system is there. Then what? Then reflectance measuring systems. See, there is two sources of lights are there, and one detector is present here. When light is entering to this food surface, suppose this is food and it is a lemon lemon, and when there is light entering to this food material, there is some reflectance, and that reflectance will be detected by this detector. And next is what? Transmittance measuring system. This will what? Same here, light source is there, here food material is there, and detector is here present, and by that the transmittance is measured. Okay. Then X-ray and computed tomography. See, X-ray, we know we are regularly using this X-ray for checking the damage in bones. We cannot see bones from our eyes directly through the skin, but this X-ray, by the help of computed tomography, we can see the structure of the bone. Likewise, that same technology we can use to check the quality of the food product. Okay. And we know the wavelength ranges from what? 0.1 to 10 nanometer, and it has low penetration power. Detect internal density changes and structural discontinuities caused by voids, cracks, density variations. Then determine bruisings, water content of apples. Select mature lettuce heads and detect hollow heart in potatoes. Hollow heart potatoes is a great problem in food industry. If that can be checked, then it will be a great thing. By the help of X-ray technology, we can use it. Then split feet in peaches, etc. Then studied the internal. Some scientists have already studied the changes occur in peaches with time when stored for 2 weeks at 25 degrees centigrade, 75% relative humidity, and suggest that what they have suggest, presence of voids, lower moisture content and lower density fruit tissue lead to low X-ray observed. अगर वहाँ पे void है, lower moisture content है, और डेंसिटी ऑफ फ्रूट टिश्यू का भी अगर कम है, तो उसका क्या होगा ना, एक्सरे ऑब्जर्व कम हो जाएगा और इमेज को थोड़ा डार्क कर देगा. देन करस्पॉन्डिंग टू ए लो सिटी नंबर ऑल्सो, सिटी नंबर इज ऑल्सो लो. Then moisture and density reduced significantly from 84.6% to 62.6%, and from 1.082 to 955 gram per centimeter cube, and soluble solid increase from. So all these changes can be checked by the help of CT number and X-ray observed capacity of that particular fruits, and based upon that the computer will check the proper fruits and not proper foods, and computer will decide to send the right fruits to the market. See, these are all the images, different images having different relative humidity, different shapes, different the gaps inside the fruits. All these things can be checked by the X-ray images. Okay. Then mechanics. By the help of mechanics also, we can analyze the food products. So ultrasonic waves above the range of human hearings, that is 20 kilohertz to 1 metric hertz megahertz, and acoustic sound waves in the range of human hearing 20 hertz to 20 kilohertz are used to evaluate the quality of fresh vegetables non-destructively. By the help of ultrasonic waves and some acoustic sound waves, we can check the quality of the vegetables, whether it is fresh or not fresh. See, ultrasonic waves. What is the principles? Ultrasound is generated by a transducer containing a ceramic crystal which is excited by a short electrical pulse. Having several sine cycles, is converted into mechanical waves that propagate as a short sonic pulse. And what is the use and application? It is used to quantify relation with the ripening, maturity, firmness, and other internal quality of fruits and vegetables. We can quantify ripening, maturity, firmness, and other internal quality of fruits and vegetables. Then ultrasonic inspection of cans. See, suppose this one is the can. It is a metallic can, and we have deliberately entered some metals, unwanted metal inside this, which is also called as foreign body. Then three types of foreign bodies were deliberately inserted into it. FB1, a rock of dimension 60. This one is FB1, and one more is aluminum plate of dimension this. One more plate is inserted inside it, and one more aluminum plate of dimensions 121. So three foreign bodies we have inserted inside the cans deliberately, knowingly we have inserted, and we have to check whether our system is capable to check that foreign body or not by the help of acoustic or ultrasound. This ultrasonic sounds we can analyze it. See, different spectra are generated. This is called ultrasonic images of canned products indicating presence of foreign material. See, this is the image, and the reading is like this. See, this part of the reading is the normal part, and that is the can. See, this is control, normal can. There is no foreign body inside it, and you can see there is no any reading in this part, but there is some reading in this part, and this part. So this part reading is due to this foreign body 1, foreign body 2, foreign body 3, and when the reading will be appear like this, the system will recognize it correctly, because we have already given library to the system about the control, we have given, and the system can recognize what is the difference between control and the foreign bodies having canned. So what will happen, the system will order that to remove these cans which is having some foreign body. Suppose you have purchased one canned product, and in that canned product you have got a metal piece inside it, then what will happen, the reputations of that seller will be gone, and next time you will not go to purchase that particular product. So that's why you have to use this ultrasonic technology for canned food. Then acoustic principles. See what happens in acoustic principles. One tapping systems, which is also called as thumper. Here one thumper is there, which will beat which will strike that food product. Suppose this is one melon is there, watermelon is there, and this tumbler is there. So this thumper will do what? It will strike this thumper and create some sound, and there will be some mic inside this, near to this place, and that mic will send the data to data processor to the CPU and make some decisions whether the sound coming from that product, from that particular food is up to the control, up to the standard or not, and based upon that it will decide the product is good or not. See, the acoustic emission AE is an important attributed quality of food textures, especially snack type of foods. The crunchiness and crispiness which are noticed as signs of freshness are other aspects of acoustic properties, and alterations of food textures can be measured by analysis of the emitted sound. Okay, then e-nose, it is called electronic nose, and the system that study is called biomimetics. It will mimic the human nose. What happens? See, your nose cannot check poisonous material or any material which is very bad or like that materials it cannot check, and the human sniffers are very costly also. So electronic nose is a device intended to detect or identify and quantify specific components of odors and flavors. सैम्पल डिलीवरी सिस्टम कैसे होता है? इट जनरेट्स ए हेड स्पेस एंड injects that sample into detection systems. Headspace matlab some space creation will happen, and in that space some flavor will be there, and that space within that space that flavor or the sample will be injected to the detector, and the detection systems react to the presence of volatile compounds, undergo chemical changes and produce usable signals. Based upon the input from that signal, some usable signal will be generated, and that computing systems, what will happen, combines the response of individual sensors elements and generated sample information, then it will create the information. See what the sample is here, the sensor is fitted here, and the raw data acquisitions will be happened here, and the signal will be gone, and we have a library of different samples, and it will cross verify that data and create one decisions whether the sample is having good flavor or off flavor. All these things it will do. Okay, so with this we have understood about the non-destructive methodology of analysis of food. Thank you a lot.